Brett, we are live on Facebook and the webinar is being recorded.
Okay, very good.
Okay, very good. So let's start.
Okay.
So we'll take a few minutes for people to join.
Okay.
And welcome to the monthly webinar on data science. This is our session number 3, a data science and analytic thought leadership webinar by IndustryX. And we welcome everybody to this program. And in the last 2 programs, we have covered the basics of data science. And in the last webinar, we talked about the roadmap to implementing data science at a company or a facility. And the reason that we are doing these webinars is data science being so important, so key to the success of the organizations these days. And at IndustryX, we like to play our part. We like to promote awareness and adoption of this technology within faculty, within students, within the industry. And today, I'm just so excited today that we have one of the best gurus, in my view, from data infrastructure that I know. Brett Wormett is joining us today. He's a GM, and I'm gonna maybe give an opportunity to him to introduce himself. Go ahead, Brett, please.
Yeah, thank you, Norman. My name is Brett Vermette, and my role at GM today is I'm the global director that's responsible for our big data and high performance compute infrastructure and engineering, as we call it, and essentially responsible for providing the company with all of the storage and compute infrastructure and resources, platform software that we use to power our data science analytics and many of our product development practices across the company as well. And one of the other connections I have with Wayne State is I sit on their industry advisory council for their data and analytics graduate school program, which has been a real pleasure, and getting to know the faculty and some of the students and so on at Wayne State. So that's another role that I've been playing that's been enjoyable for me.
No, it's welcome, Brett. It is a pleasure. And throughout the last few weeks, I learned a lot from you in this space. So welcome to the program, and I hope that our audience will benefit from this program as well. And then our one and only Dr. Chenam Babu, go ahead, please.
Sure. Good afternoon, good morning, depending on where you're calling in from. Pleasure to have Brett Wormett with us today. Learned a great deal from him over the past decade with all his thought leadership talks in the AI, big data and analytics summits at Wayne State, as well as his role in the advisory boards, trying to shape our data science and analytics programs. I'm a professor and chair for the Industrial and Systems Engineering Department at Wayne State. I lead the AI, Big Data and Analytics group, and along with Noman, we co-founded IndustryX, Center for Operational Excellence, that tries to leverage advanced technology and AI to advance operations. Have 2.5 decades of experience in assisting businesses across industries in their journey into data science and analytics, whether it be for supply chain operations, manufacturing operations, product development activity, quality management, things of that sort. So excited to be here today and looking forward to a rich discussion with Brett and Noman on the importance of data infrastructure.
Good. So welcome both of you. And to the audience, if you have any questions, you have any comments, feel free to raise your hand. There's a chat box. Please use the chat box. We will be monitoring the chat box for your questions. And we will leave some time at the end for any questions as well. So let's start the program. So just like Babu mentioned, that IndustryX is a center of operational excellence powered by advanced technology and AI. The focus that we have right now, or the focus, or what we are trying to do is we're trying to support regional resilience. We like to support workforce development, and we like to make an impact in not only Detroit, in Michigan region, but globally, as we embark on Industry 4.0 and this technology, to make an impact and make our contribution as well. We've been working with a number of universities. We've been working with a number of global organizations as well. For example, World Economic Forum. They've been working with us, and also working with a number of other companies. For example, Siemens, Microsoft. We will be announcing a very important program that we are developing with Microsoft to bring data visualization to the industry with the help of our students as well. So if you want to know more about these programs, if you want to be part of these programs, if you're a student, you want to be part of our team, if you are an industry technology company, you want to contribute to regional resilience, workforce development, let us know, reach out to us, and we would be very happy to work with you as well. So with this, data infrastructure enables competitive advantage, and we have seen that how companies like Google, companies like Netflix, Microsoft, and companies like GM, they are using data science and data infrastructure for enabling competitive advantage. So I want to ask, I want to kick this off with Brett asking a question that, how do you see data infrastructure being in the data science sphere?
You know, it's interesting, Noman, as you start to think about that, right? And the digital economy that we all operate under is changing so quickly and under so many different pressures. You know, if you think about the obvious one is the impact of the global pandemic. We've seen some severe weather incidents like what happened in Austin, Texas, for example. Many companies are now dealing with a semiconductor shortage that are impacting their supply chain. And, you know, in order to operate in fast moving economic conditions and fast changing economic conditions, we all need good insights to drive our decision processes. And, you know, the insights that we get from data science and the practice of analytics and data science are absolutely essential to competitiveness from my point of view in this economy that we operate in. You know, being from a manufacturing background, I've been in the manufacturing industry most of my career. You know, I tend to think of things in those contexts. And if you really think about those insights being the product of data science, we often talk about at GM that the data that we use to produce those insights is like the raw material that you would transform and construct, just like you would producing a vehicle. You use that raw material instead of sheet metal and plastics and so on. It's data, and that data gets transformed into those insights that power the competitive advantage through the use of the data infrastructure. It is really the machinery that powers the competitive advantage that is brought to the table by using insights. You know, and as you look at some of the companies that in the world that are perhaps some of the foremost experts and have taken, you know, a leadership position and taking and using data science and insights to power their business, Netflix and their recommendation engine is a really big example. Netflix is one of the world's largest consumers of public cloud services, and you know, I am a avid Netflix customer and I rely on the recommendations, and it's pretty interesting how accurate it gets, right? I don't find too many recommendations that aren't to my taste. So that speaks to the accuracy of the models that they've developed based on my watching habits and other demographics that they've gathered, right? So without that, Netflix business is not what it is today. Amazon is an interesting company because they have, of course, their web services and cloud compute capabilities that provide the infrastructure that power the same insights for many companies. But also Amazon is one of the biggest users of insights as you look at, again, their recommendation engine and all of the data that they use. Again, during the pandemic, myself and my family have just become avid Amazon customers. And I suspect most of us on this webinar are as well. But they are kind of on both sides, right? They're insights consumers as well as providers of insights or machinery that powers insights. Microsoft and their Azure program is one of the biggest cloud compute providers in the world, and they power analytics and data science for many, many hundreds of companies around the world. And of course, Uber and their global presence and matching customers with driver availability on a micro level, operating at a macro level around the world is pretty impressive use of analytics and data as well. And then of course at GM, near and dear to our hearts at GM, we're using data insights to power everything from vehicle safety improvements to warranty claim, analytics to predictive analysis that allows us to let you know that you have an impending failure in your vehicle that you can have serviced as opposed to waiting for it to fail, to powering some of our biggest investments in new technology in the electrification and autonomous vehicle programs that we're driving around the company. So, these are just some examples that I was familiar with, and I know there are hundreds more out there, and it's becoming ubiquitous. It's everywhere in every industry around the world as the digital economy grows and as scope and scale of operations grow to be more and more global every day.
So Brett, I have a question for you. Like
Sure.
when we look at, a company like Uber, right? It's really a digital company, first and foremost, right? Born through analytics kinds of a company. But, vast majority of the companies are not where, these digital companies are. So what is your perspective on recognizing the importance of data structure, building the right kind of data structure to enable the more established companies, right? In particular, the companies around us in the Midwest area. So before we delve deep into this, what are your thoughts? Where are we? Are we still way behind, these kinds of companies, not necessarily GM, but most of the companies around us?
It's interesting, right? Because there's so many companies like Uber and even Netflix. I mean, my first interaction with Netflix was getting a CD or DVD in the mail, right? And so they have changed and transformed their company as well. Companies that are, what I would call internet age companies do have somewhat of an advantage because they're building their whole data infrastructure and all of their practices and business processes around analytics, as opposed to companies like GM and some of the other auto industry companies and many, many others that have a long history, right? Even predating the information age, that there's more adaptation and I would say re-engineering of processes and practices, and even cultural changes that are sometimes the technology is the easiest part of the whole thing, right? If you as complex as that can be, the human change elements of this and trying to get senior leadership in companies to trust the data. And I could give you many examples where we put data in front of some of our senior leaders about different things like warranty claims and sales and those sorts of things. And they can't believe what they're seeing. This must be wrong. And so they send you back and they ask you to look at it again, and you come back and the answer is the same. And you might go through a couple of rounds of that. And that's as much about the cultural shift as well, right? Often overlooked. But I think, on one hand, the companies with a long legacy have supply chain capabilities and, engineering capabilities and other capabilities that are well refined and honed over years and years of evolution. That's an advantage, but they also are encumbered by the legacy of, multiple systems. And we'll talk a little bit more about GM's history as we go through this and how it's taken some significant effort for us to even grow beyond where we were at the point of Y2K, for example, right? So.
Right. So Brett, when I look at GM and I was looking at the history of GM has grown over the years with several acquisitions, functional units. So it's a very large organization, and to put this program, this data infrastructure program in GM, how do you see it, and what is your some of the lessons from your side on this in this area in the development of data strategy, architecture, and infrastructure?
Yeah, as we're preparing for this, and I started thinking about, the history of GM and the legacy that we have, and how it's been impactful to our journey, right? Even in the most recent years, you go back, there's over 110 years of history since GM was founded in 1908. So that's, a long legacy, very much predating, any thought about data and any thought about, analytics and data science and even a computer, if you really think about it, right? But GM was formed from a number of different acquisitions, especially in the early days, and some of the brands that have now been even deprecated were very foundational to GM's history. Oldsmobile and Cadillac were the two brands that were initially part of GM, and then GM was incorporated and at the same time acquired Chevrolet, and then acquired Vauxhall in England, Opel in Germany, Holden in Australia, Pontiac Motors was created, not to mention Saturn that was created in the 80s, etc. The thing that was really impactful in all of this is that the organization, GM as a corporation, was really run as a set of what we call loosely coupled operating units that were run independently and had autonomy to do as they saw fit. So as the information age evolved, each one of those organizations evolved their own data centers, their own set of applications, which in turn came with their own set of data structures, lacking of commonality across the whole GM landscape. And it left us with a really big challenge, right? Back in the 1984 timeframe, some folks will remember Ross Perot and electronic data systems, but GM acquired EDS and transitioned all of the IT staff to EDS. That over time evolved into not just EDS, but 7 different outsourcing partners, supporting all of those independent operating units, further complicating the lack of overarching strategy. And there was some GM IT folks that were involved in trying to drive strategy, very challenging across that very diverse environment, right? One of the key things in 1996, and you'll see as we talk about the key use cases that are driving the data architecture, the launch of OnStar and the connected vehicle program. And initially it was much smaller scale than it is today, but today we're now north of 11 million connected vehicles on the road. That is powering a lot of the analytics that is happening around the company, and the use of the data that we get from vehicles that allows us to do some of the predictive analytics I mentioned, and pulling what we call diagnostic trouble codes and environmental information so that we can predict when your fuel pump might fail, when your battery might fail, when your starter might fail, and have an OnStar agent reach out to you before you have a vehicle failure event and schedule a maintenance so that we stay on top of that. Back in 1998, and I was closely involved in this, what was called the Automotive Components Group, with about 200 manufacturing plants, was spun off from GM into a separate entity, which, the Delphi apple didn't roll very far from the GM tree, really, right? And when you think about it, Delphi was also challenged with a very diverse set of, I think there were 7 divisions at the time of formation, each with their own set of application systems. And I put the Y2K milestone on here, not that Y2K in and of itself was all that relevant, but it was the very first time that we had done a thorough and accurate inventory across all of those operating units of the application systems that were supporting GM. And when we stopped counting, and I do say stopped counting, not found them all, we had over 7,000 application systems across the GM landscape. When you start wrapping your head around that, 7,000 sets of databases, and thousands of separate perspectives on something as core to the company as what does a vehicle look like, and what is the all the attributes that went with it. The diversity of the application and data landscape was enormous. And so it was back in 2012 when Randy Mott joined GM as our new CIO at the time that we launched an IT transformation to, I would say globalize GM's IT operations and address some of these challenges that have grown over more than 100 years at that point, right? When you really think about it, and largely in the, from the early 80s, some of that stuff started to be constructed and so forth, but still a long legacy. And a part of that transformation was the launch of what we at the time called our data warehouse program, or our enterprise data warehouse program. This was GM's really, truly first attempt to build a common data infrastructure and data and analytics program common across the company. And we found that we had what we call data and analytics marts, but think of them as independent reporting environments that were powering some level of more reporting than analytics at the time, but were powering a lot of the sort of descriptive analytics, we would call it today. There were hundreds of them. And so we set about the task of eliminating those, consolidating them, and driving commonality in the data architecture and the infrastructure that supported the practice of analytics at the time. We also started a program that we called HyperIngest and back in 2018, where our data engineering team built automation that was intended to populate the data lake. And quite frankly, to coin a famous phrase from a movie, if you build it, they will come, was our exact mantra, right? So the idea was to populate the data lake with all of the data from all of the key application systems, because one of the things as we started the transformation, we came to realize there were literally tens of thousands of man years spent every year trying to locate, harvest, and consolidate data just to power a decision process, right? So the idea here was to co-locate the data, catalog it, and make it much more discoverable to accelerate the practice of data science and analytics around the company. And it was back in the 2018 timeframe where we started streaming telemetry data from the OnStar connected vehicles. So think of this as every OnStar connected vehicle on the road streaming its location, direction of travel, and its speed every 3 seconds while it's being driven. And we have that in place today, and that data is powering analytics and many, I would say very material data science activities across the company as well, up to 400,000 transactions per second at peak drive time, and typically about 15 to 18 billion transactions a day. So fairly significant volume of data to sort through, right? So, and then today we're really continuing to evolve our infrastructure. I'll talk a little bit more about it later, but how do we keep up with the changing technology at a fairly massive scale? Tens of thousands of compute cores, tens and headed to hundreds of petabytes of data, and managing all this in a way that allows our analytics and data science community to actually consume that volume of data. So if you go back to, you say, to the point, in the question you asked earlier, the disadvantage of GM's long history was the encumbrance of all this diversity in the systems and data landscape. And then how do you bring that all back together in a meaningful way to really become, I would say more global, more central, and really power the company with a data orientation as opposed to, independent silos doing their own thing, right?
So
Wow.
a question. I mean, this is amazing, and GM is of course a truly multinational corporation. I mean, the largest such enterprises that exist. Mm-hmm. So the people that are in the audience, Brett, wondering, okay, GM is this big company, has the resources, they have tens of thousands of applications, and maybe have the power to get these vendors to sort of think differently and support the centralized, data lakes and things of that sort. So what is your advice for a medium-sized company? I run my supply chain. These are the tools that we have. How do I basically get to the single source of truth, right? So that the entire enterprise can basically begin to understand at least, what the data is telling us, and then I can work towards building these analytics layers on top.
Yeah, and from my vantage point, I think some of the lessons that we learned since we started our transformation back in 2012 are very scalable up or down to smaller companies as well, right? And I think it's really critical that you start by taking an honest look at your current state, right? Part of your current state is, understanding this applications landscape, understanding what your capabilities are in terms of data center competency and so on. In today's world, one of the advantages that small to medium-sized companies have is you don't have to stand up a big data center and have a lot of, I'll call it data center engineering expertise, because the public cloud is available, right? So that takes a lot of that off the table, and we can talk a little bit about, GM's approach, but we do have the luxury, as you mentioned, of having scope and scale and some of the talent that we have on the team. But, starting with an understanding of where you're at from a systems and data landscape, from an infrastructure capabilities perspective, and also from a talent perspective, right? As much as anything else, we're talking mostly about the technical infrastructure today. None of this stuff happens by itself.
Exactly.
You have to have the talent on hand, and that talent can be acquired. You can hire them directly. That talent can be augmentation for your organization through, consulting partnerships or service partnerships, and you can actually buy some of that talent through cloud services as well today, right? So I think you have to really take a look at, number one, where you start. And then I'm a firm believer in beginning with the end in mind. And, I've learned a lot over our last, 9-10 years that we've been at this in the transformation business, and really look at it and think about, how is it that what's the vision, right? And you begin with that end in mind, and that becomes the guidepost. And frankly, the vision can change over time because the business circumstances change. But what I find is it changes, somewhat, let's say a little bit east or a little bit west of north, but it's not going to change, and you're likely not going to have a full reversal and head full south. So if you assess your current state, you really take a look at and frame out a vision that the organization can rally around. And ours was one single enterprise data warehouse. That's where we started. The vision was very clear. The vision was ambitious. It was aspirational given where we were, but there, and we're still working toward that. But at the same time, that really has been pretty durable and hasn't changed much. And then the in-between, you can figure out along the way, right? That's at least my first thought on that.
Yeah, Brett.
That's excellent, Brett. Just a 1 minute, Brett, on this one. What are the key strategies that has driven the evolution of GM's data structure? Just give us a.
Yep. So I would start off with the very first thing is, as we took a look at ourselves and assessed where were we in 2012 at the beginning of the transformation, there were literally no less than 27 data centers around General Motors. And we set about the ambitious task of, with the exception of what we call remote hosting centers that are in the plants and in a couple of the large regional engineering centers, and that's done just for latency purposes and for reliability purposes. The vision was we will have 2 enterprise data centers for the entire company worldwide. And we've largely achieved that. So that data center consolidation helped us drive co-location of all the applications, right? Which made a lot of the challenge of building what we originally called our enterprise data warehouse, what we now refer to as, and you'll get this in a minute, the naming convention, but the Galileo data and analytics platform, because the evolution from a traditional data warehouse to an analytics platform and a data lake or a lake house, depending on the terminology you want to use, was key. So the data center consolidation powered that. We did start a program to build our own private cloud infrastructure. And this is where we take advantage of the scope and scale of GM to build a lot of the cloud-like services on-prem, and we get some cost advantages and some agility advantages. But we have a 10,000 person IT organization, which is bigger than a lot of companies, right? So not everybody would choose to go private cloud, but it's the same principles, 11-factor applications and elasticity and all of those things that drives our analytics program. We just chose to implement them on-prem. And now if you're listening in the news about GM at all, you would have heard an announcement of a partnership with Microsoft and Azure, and we're exploring opportunities and how we can leverage them to help power and accelerate our autonomous vehicle programs and our data and analytics practice across the board. And we're in the early phases of what was a 10-year agreement with them. So lots of work to be done. But we are moving to help augment our footprint with the power of Azure as not exclusive, but our preferred cloud provider in the public domain, right? And I mentioned OnStar connected vehicles, but it's as you can well imagine, we think of this as a huge competitive advantage in the rich source of data that we get from OnStar. Everything from, the connected vehicle telemetry data that we got, the prognostics and predictive analytics data we get to help with customer failures, vehicle safety events, and all of those things. If you're familiar with OnStar services, you can go in, for example, and go onto your mobile app that comes, your My Brand app, like your My Cadillac, My Chevy, whatever, and you can get a smart driver score. It helps you improve your driving habits. Well, that smart driver analysis is powered directly out of our platforms based on algorithms that have been built by our data science team to help people understand how to improve the safety and efficiency of their driving habits, right? So, and recently announced GM's getting into the insurance business with OnStar Insurance, and that's another business model that's being entirely powered by data that comes through our data science practice, right? And are all powered on the infrastructure we're talking about today. Electrification and autonomous is, two of our driving forces that are changing GM's product portfolio. By 2024, we'll have 25 different fully electrified vehicles available for purchase in the market. And today you'll see a lot of news about our Super Cruise, which we call it a semi-autonomous driver assist, but you can get on the highway and drive for hundreds of miles without touching the steering wheel today. It's not urban driving capable. We have other autonomous programs with cruise automation running out of San Francisco that they are developing robo-taxi capabilities that'll basically be urban driverless vehicle capabilities that are headed toward the market in the coming 2-3 years, as well as the next advancement of Super Cruise. And you're going to see a continuous advancement of, autonomous driver assist and going to level 3 and level 4 autonomous vehicles. Much of that engineering work is powered by data science and predictive algorithms for powering the analytics that will run in vehicle, that'll be the guidance systems to recognize objects on the road and respond appropriately. And to your point, I think, Babu, you made about mid-sized companies, much of what we're doing is powered on open source today. And we're moving more and more toward open source. That technology is widely available. I don't want to paint the picture that open source is free. There is no acquisition cost associated with the software, but there is a cost in terms of engineering and staying current and contributing back to the open source community that you have to think about. But those technologies are widely available. Everything from the legacy Hadoop ecosystem that was one time the darling in the industry and now is starting to be thought of as legacy, right? And it's like looking at my teenager and calling him old school and legacy. That's kind of how fast things are changing. But some of the new things merging with Kubernetes and Spark and containerization and infrastructure as code and some of those practices, it's all driven from open source. So we're moving in that direction so that we can keep up with the innovation that's occurring in the industry, because frankly, the open source community innovates at a rate far in excess of commercial software companies.
Exactly, Brett. And that's the reason why in many of our programs, we work with the primarily open source platforms, because there is a very big advantage to working with the state-of-the-art methods and libraries and things of that sort.
Yeah, and we love that when we hire graduates coming out of programs like that, and they're familiar with these technologies, and we're in a good position then to have them be very productive very quickly, and they bring thought leadership to us right out of the whether it's undergrad or graduate school programs that they graduated from, right?
So Brett, I mean, you talked about all these great applications, Super Cruise and all these kinds of things, and the bedrock foundation that powers the machinery that would allow you to develop these kinds of applications is all this, important infrastructure. So talk to us a bit about what that infrastructure would look like in a company like GM?
You know, when I really stopped and thought about the question, you know, it occurred to me like, what's, you know, and think of it from this perspective, what's a day in the life of a piece of data? And, you know, and how does that data relate, that piece of data from its inception and creation through its consumption and production of some insight that it contributes to, how does it interact with the infrastructure, right? And the very first piece that starts at the top is the data gets collected. You have to have a mechanism to actually gather and collect that data. And in many cases, it needs to be transformed in some way. Data coming off of our vehicles are encrypted in binary blobs. And so all of that needs to be decoded. And as you can well imagine, with 11 million vehicles on the road, for example, there are vehicles of varying ages. The hardware, there's a lot of heterogeneity around the hardware that's in the vehicles. So there's a lot of transformation that needs to be done to the data. So the very first step is you need to have the processing and data collection capacity to be able to gather and transform and curate that data, right? That's where it starts. Unless you can gather it, you can't gather your raw material. It's very difficult to actually consume it in any meaningful way, right? And so now that you have that piece of data and it's been gathered from you know, a machine controller in the plant, from a mobile device, from a vehicle, from an application system, from an internet source, you got to put it somewhere, right? So you need a data persistence layer of some kind. And, you know, traditional storage technologies and databases at the scope and scale that even small to medium-sized companies are starting to deal with put a lot of pressure on what would be traditional relational database technology. And so having very high capacity storage is absolutely required to support contemporary use cases. And when you really think about it, it has to be a balance between performance and cost, right? As data grows to hundreds of terabytes, tens of petabytes, and beyond to hundreds of petabytes, you can't keep it all in flash. You can't keep it all on SSD high performance storage, or you could, but you probably won't be able to afford it, right? We can't afford it, and I can speak with authority on that. So we're starting to seek technologies that help with, you know, cost-effective archival and storage of data. And what we found is that a lot of the data consumption patterns focus on, you know, whether it's 6 months, it depends on the use case, but typically any data over 6 months is used very lightly. And as data ages, the consumption of that data, the rate of consumption decreases, but there's still value associated with it. So how do you archive it and so forth, right? And then of course, when you're talking about very large scale data, you have to think about large scale compute to be able to consume it. The largest table in our data lake is now north of about 12 trillion rows and growing every day. And you know, you don't just run a select against that and hope that you get the results back. You have to have the right data structures in place. You have to have the right compute capacity in place to be able to consume that data and put it into some form that's actually something a human can use as to derive insights and support a decision process of some kind, right? Then the next piece, and it's kind of in parallel with collection, persistence, and consumption, but none of it's possible without the network connectivity in between, right? So people often overlook network connectivity, but moving large scale data from the very edge, wherever it's collected, into your analytics environment, be it in the public cloud, be it in a data center or some hybrid model, requires high performance network capacity to be able to move the data. Otherwise, it becomes a very significant impediment and people just, you can't gather the data, you can't consume it, right? And then a lot of what we've talked about so far is hardware, right? Network hardware, compute hardware, storage hardware, but don't overlook the platform software components of infrastructure. Everything from, like as you mentioned, the typical Hadoop platform, you know, to other, you know, data consumption tools that are out there for allowing data exploration and data wrangling, all the tools used for data transformation, and then the software to monitor how all this is working operationally. Because what we've found is, you know, it's a little bit of the be careful what you ask for, right? Back in 2012, we wanted ad hoc data consumption, self-service. We wanted our analytics program to drive critical business decisions. And guess what? That's where we are in a lot of ways today. And that comes with the operational pressure to keep it up and running, right? Because now you have critical business processes that stop if these things aren't in place. So gone are the days of the enterprise data warehouse that nobody noticed if it was down for a couple of days because I didn't really need the reports anyway. Then the last couple of pieces, one is around business continuity. Don't overlook the fact that as these data and analytics resources become more mission critical, you have to have a way to protect them from at every level, right? From hardware failures to data center failures, network failures, cybersecurity incidents, all of those things. So, we invest a lot of time now thinking about how do we protect the continuity and the value invested in those data assets. For example, I talked about vehicle telemetry data. There's a lot of value for us in that. You can't call a vehicle and ask it to send you its location information from a year ago, right? If you lose that data, it's gone forever. So we're very careful to protect those assets. And then the last thing that we're starting to see now, and it's more an emerging area for us at least, and I think for many, is how do you push edge compute capacity, or the compute capacity out to the edge is probably better said. Because really at the end of the day, the data volumes that are potentially collectible are enormous. Absolutely enormous. And processing that and pulling the value out of it and pulling the value back and collecting only the relevant pieces is becoming increasingly important. And actually, to drive not only for gathering data for model development and training, but capacity at the edge for inference is becoming more and more important as well as you look at data science, right? And we were preparing for this, and we talked about the kind of amusing use case, but if there's a vehicle that's reporting its location information every 3 seconds and it sits at a railroad crossing for 10 minutes, how much value is there in the data during that 10 minutes? Exactly. And frankly, we are still collecting that and trying to figure out how to sort through that right now, right? So
that's a really excellent characterization of what constitutes infrastructure to be able to empower, right, a data-driven business, right? Mm-hmm. It really becomes mission critical, and GM is really a big company, and no one is taking us to how to sort of get started kind of a discussion. But a lot of these small companies, they don't have to do it on their own, right? They can work with partners to get started, and these cloud platforms are a big way to get started. So you don't need to, acquire all that hardware and all that talent on day one, right? So, and you can scale and then figure out, what is the right solution for you.
But, yeah, and I think, Babu, to that point, one of the things that we learned early on, and you're right about our scale, and I don't want to, just take that lightly, because we do have the luxury of having that kind of scale. But at the same time, back in 2012, when we launched our data warehousing program, it started with 3 reports, reporting on daily manufacturing results.
Okay.
And so you can start small, right? And that's the thing that one of the key lessons I learned is, start small with a lead use case that you intrinsically know. You may not be able to have hard numbers against it, but you intrinsically know there's value. And then you will build momentum, right? Success engenders interest and more success. So I think, we started as big as we can be sometimes. We started with 3 little reports, right?
Right. So Brett, I know this is great, and at least for me, is quite overwhelming. All this, the infrastructure and the amount of work that you guys have done. But for someone or companies like Babu, keep going back to small and medium-sized companies, because we see that in order to build regional resilience and to develop stability in our economy and in our, especially manufacturing, these small and medium-sized companies are important. So what are some of the starting points? How can someone, maybe our listeners, they can start a journey on this data infrastructure journey?
Sure. I think at the end of the day, right, we touched on it earlier, take an honest look at your current state. And as you start to look at your current state, assess yourselves in terms of, where are my business needs? what are my current capabilities, whether it's hard infrastructure capabilities in the data centers or hardware and software, whether it's your data science and analytics talent, where am I at organizationally and culturally? But then, I really think regardless of the scale of the company, you really just need to stop and take a hard, honest look at yourself from a current state standpoint, right? And, one of the things we did is we recognized that we had a certain degree of bias, so we brought an outside partner in to help us to help us with, I would say an industry viewpoint, or beyond the auto industry, more of an IT industry viewpoint, but also to help balance the bias and that we all intrinsically had, having been around GM for a long time.
I was just about to ask that, Brett, because you don't know what you don't know, right? A lot of these companies don't know what what's happening out there, right, and where you are. And it's interesting, even the biggest companies around the globe, GM, you guys brought in outside experts to help you go through the current state assessment.
You bet we did. Yep. And it's interesting, right? Because you're right, you don't know what you don't know, and you also don't know what you think you know, right? So like that's one of the lessons I learned, because having been around GM for a long time, I had a certain perspective on things, and bluntly could be kind of defensive, right? Because in some ways there was a big part of my own personal self invested in where we were, and it really did help. It hurt a little bit from time to time to really get somebody to come in and tell you that there are issues, but you need that, right? Because otherwise you're starting from a false starting point. And then I think it really is to define your strategy and, begin with the end in mind. We talked about it, but tied to key company business objectives, but, identify those lead use cases. And it doesn't have to be a big use case, and we'll talk about ROI in a minute, but, you're going to have to make a bet, right, in some ways, and to get the ball rolling and make those initial investments in that foundation. And that foundation could be, set up an account with a public cloud provider so that you have a mechanism to grow. Or maybe you do have some infrastructure in-house today that you'd like to build on or augment with public cloud, but just build enough of the foundation to service the lead use case, and then plan to grow. Right? You got to execute the first use case, and you want it to be successful because it will garner attention and it'll garner reputation, and then you can demonstrate value to your organization, and then it will become easier to convince people to invest further, right? But plan for growth, because in today's world, I think if there's nothing else in the data space, growth is inevitable and inarguable, right?
Exactly.
Right. Brett, with this in mind, one of the first question that, and you mentioned ROI also, that companies, when they're starting on this journey, or there's some investment, the first question the management asks is a return on investment.
Mm-hmm. Mm-hmm.
How do you justify this case? What are the key what are the key elements of this ROI strategy? How can they justify?
Yeah, and let me just give you what my thoughts are initially to summarize. And I actually did a talk with one of the Wayne State Graduate School classes about the business case behind analytics. So we could have a whole webinar on that one day as well. But frankly, it's been my experience that it can be paralyzing if you get bogged down too much at the very beginning in the initial use cases of trying to establish hard value and justifiable and what I would say fully cost justified business case. There is a bit of an entrepreneurial or almost like venture capital approach that there has to be an initial seed investment that is funded at the very senior levels in an organization, whatever that means to each person's company. And we had the luxury of having Randy Mott come in as our CIO. He had been at Walmart, Dell, and HP and had a vision for this. So he provided that senior, almost like we thought of him as our VC investor, and we had to go back and demonstrate value to him, right? But as you really think about the ROI question in developing a business case, at the end of the day, it's got to be business outcome based. It's not about how much data you have. It's not about how many reports you have. It's not about how many queries get executed. It's can you tie the investment back to some business result? And that's where it's really strategic to select the right use case off the bat that supports a strategic business priority that can demonstrate verifiable value. Now, it doesn't have to be verifiable to the penny, but how do you support those strategies at that level in the company? And then you have to convince senior leadership to invest to seed the foundation and prime the pump and get it rolling, right? It's also really important that you recognize that it's not a straight line path on any of this stuff. It's a very iterative process. And one of the things we learned that was part of the rationale behind the hyper ingest program to get all of the data in one place. Many times as you seek to solve a problem, a business issue, or think about the impact of the pandemic, or more recently, we'll talk about even more sort of tactically, the severe weather in Texas impacted our Arlington assembly plant, right? And how do you respond to that? If you can't move fairly quickly and in an iterative manner, by the time you work it all out, what's going to happen is you're going to come back to the question with an answer, and the business will have moved on, maybe 2 or 3 times. So you got to recognize that it's a very discovery and iterative based approach, that it's hard to define the value, and you'll find value along the way, and you have to trust that notion, right? You got to think cross-organizationally, because if you're in a, say, supply chain or whatever, finance, whatever your functional silo is, the value will grow exponentially when you reach out across the functional boundaries within the company. And think about the whole stack, right? Hardware, software, human capital, services involved, because you are going to need all of those things, whether you have them yourself, whether you buy them through a cloud provider or through an outsourcing partner. You're going to need to really think about what you need on the full stack to execute. And one of the things we're starting to get better at, and it's been a journey, is how do you tie the solutions that get built back to utilization of the infrastructure? What we found is some of our biggest consumers of infrastructure services in the company ended up being some of the lower value generating solutions. So trying to tie that back and trying to be economical and continuously evolve the efficiency and the use of your infrastructure. We look at things as simple as, okay, I'm storing data for 15 years and nobody's accessed anything older than 6 months in a year or two. So, what's the value of continuing to persist that, and just putting those ability to tie your solutions back to the utilization of the infrastructure, which drives cost, whether it's in the cloud, whether it's on-prem, whether it's a hybrid model, it all drives cost. And then you need controls around that, right? Especially given the elasticity of cloud computing. You have to be careful that you put the right controls, or else you might be surprised when you get the utility bill at the end of the month, right? And it's the same thing as constantly reminding your kids to turn the lights off when they leave a room. But at the same time, we don't have that issue because we're largely on-prem, and we'll see where we go with Azure and so forth. But we also have the other side of it, is it's much more difficult to be elastic, right? So there's a balance to be found there. And just always continuously evaluating and looking for improvements is part of the ROI, right? So understanding the value being generated and looking for more opportunities and trimming back on those opportunities that are no longer of value. Hopefully that addresses the question you asked, but that's
Sure.
the point of view that I have on that one.
So as we come to the end of the webinar, Brett, I think we have a couple of minutes and maybe we should take some questions as well. So, when I look at the technology landscape, it is just overwhelming. I mean, technologies are popping up every month. So if companies are thinking, this is, in rapid flux, am I committing to platforms that will be outdated in 6 months? This is an expensive proposition. How do I sort of manage? What are some of your thoughts? Like, I mean, should I keep waiting for this technology to mature?
Yeah, and it's funny that you say that. I'm of the opinion that it's best to jump in, right? Because if you keep waiting for the technology to mature, I think about the memes you see around that has the skeleton in front of the computer board, keyboard, right? You will be waiting. That the industry is going to continue to evolve. It's never going to stabilize. I think the most certain thing in the industry is that it's going to be constantly changing. So that's a piece of, I wouldn't wait. I think find that use case and get started. And the learning is invaluable that you will have as you go along the way. We talked a lot about beginning with the end in mind, and know where you're beginning and take an honest look, but also have a view to what's the guidepost that's going to bring you there. Make sure you think about the full stack: talent you need, hardware you need, software you need, services you might need, not just the hardware. Because, I get into a lot of infrastructure conversations, and shoot, there's, a lot of it is about hardware, right? Analysis paralysis is costly. We talked about venture capitalism and that entrepreneurial approach, but think of it as internal venture capitalism. There has to be a seed investment, and don't wait, right? Because while you're waiting for the technology landscape to mature, how much value is going to be, flowing by that you couldn't grab, right? And so there's a lot of value about that. Be really honest with yourself. Talent is a key piece of this, whether it's, the hands-on infrastructure engineers, if you're cloud-based, the architecture talent to drive the application and data architecture, to effectively use that, the ability to tie that back to your key business practices. Really assess and build your talent, but do it strategically in the areas that will add the most value. And then find a way to associate outcomes and value to the supporting infrastructure. Because what happens is the budget line actually is for the infrastructure. And if you're not able to associate that budget line of cost back to the value generated for the company, pretty soon you become a cost to be controlled and managed down. And that is just going to be a huge mistake strategically for any organization, in my view. We'll be left behind in the digital economy. So.
Brett, I agree with you that not only is the data exploding every day, they say every 18 months or 2 years, we are collecting, double the data that we have collected in the entire history of, of humanity. But I think technology also will accelerate. I mean, we are trying to develop better and better systems to cope with this rapid explosion, but I think we will develop new technologies. But as you say, we can't wait, because the gap between the leaders and the current players is only going to increase. So as you say, we need to get started with a focused, use case or two, and learn and be iterating, based on the experiences and evolve.
Yeah, if you're not moving in this space, you're standing still, and standing still is the same as falling behind.
Exactly.
Yeah.
Right. I agree.
Fantastic discussion, Brett.
So this, I think, Brett, you just powerhouse of knowledge, my friend. This brought so much energy to this discussion. I wanted to focus some time on maybe some of the ideas in this webinar more. Like, we wanted to talk about the make and buy when we are starting. I wanted to spend some more time on the ROI question. So maybe at a later time, we can develop maybe a further webinar. But the next webinar, I like to address the organizational piece of that, which is, you also discussed, assess your talent and build a team, build an organization around it. So I want to talk about that in the next webinar, where on May 27th, we're coming back with you and Nabil, both like veterans in data science, and obviously with Babu. I'd like to address the talent piece and the organizational side, because that is so important as well for companies when they're starting on this journey. They invested in technology, but they don't have the resources. What they're going to do with the technology? So I want to address those key points in the next session. With this, I think we ran out of time. We had a few questions, but I think we can address them maybe in the next webinar as well.
Sure.
Any last comments from you, Brett or Babu, that you want to maybe address right now?
No, my comment is, Brett, it has been a tremendous pleasure having you in the webinar series. I mean, you are truly the expert, in Michigan and around, understand these issues deeply. And then we have, raised a number of important comments. We can be waiting. This is important. I mean, on the East Coast and the West Coast, we have companies that have sort of mastered some of this. But in particular, if I look around the Midwest area, I see companies still sort of struggling to develop a strategy and manage this transformation, and a lot of great comments.
Sure. And I guess my thought for everybody who's watching would be, it can be intimidating, right? As you look at the pace of change and the technology evolution, and sometimes even the cost of some of this stuff, but don't become paralyzed by that, right? It's absolutely important to get started on a small scale. As big as GM is, we started very small, right, in this space, and it will grow, and it's very much one of those situations that will become self-funding if you attack it in the right strategic way.
Right. No, Brett, appreciate. With this, I want to end with this thought here. Supporting what Brett is talking about is think big, start small, learn and grow fast. This is the mantra of growth in this market, in this age of disruption. And you beautifully put this, Brett. So I thank Brett and Babu and all the audience who were present today, the repeat audience as well. And we'll be back next month with Organization for Data Science Analytics. Thank you and have a great day. Stay safe.
Thanks, everyone. Appreciate your time.